Okay guys, so we are now into 8.5, so we're going to start factoring, and I love factoring. It's so much fun. Okay, so first we're just going to look at factoring out a greatest common factor. And I'm actually going to zoom up in all these problems. So let's look at number 1. So greatest common factor, so GCF. We want to look at what is the highest number that can, that's my eraser, that can go into 27 and 18, as well as the variables. But I just want to talk about numbers really quick. So what is the highest number that can divide into 27 and 18? So if you need to, think of factors of 27. So that would be 1, 3, 9, and 27. And then for 18, I would say its factors are 1, 2, 3, 4, 5, 6, 9, and then 18. So now we're going to look at, okay, which ones do they share? What's the highest number that they share? And it's 9. Okay, so my greatest common, my GCF for numbers is just 9. But then they also share variables. Okay, so if I were to kind of like expand that, y and y's with 2 y's are with the 27, and there's 1 y with the 18. Well, they share at least 1 y. So I could also say that a y is a GCF. So 9y together is the GCF of this binomial. So what I'm going to do is I'm actually going to divide that out. That's what factoring is. Factoring is the undoing of multiplication. So 27 divided by 9 would be 3. And then I would take out one of the y's, and so I'd have 1 y left over. And then 18 divided by 9 is 2. And then I'm taking out a y from that, so there's no y left over. So the really cool thing about factoring is that there's a really great way of checking your answer. And basically that's just to multiply it and see if you arrive at what you started with. So if I were to kind of multiply that 9y back in, would I end up with what I started with? And I would get 27y squared and then 18y. So that's how I know I've done this correctly. So looking at number 2, now I've got more numbers to work with. I've got a -4, I've got -8, and I've got 2. Now, the one interesting thing about number 2 is that I don't like to ever have a leading coefficient that's negative, so I want to actually factor out a negative. So I would factor out a -2. That's the highest number that divides into 4, 8, and 2. And then if you notice, they all have at least one A, and they all have at least one B. So -2AB would be my GCF. So what I'll do is I'll maybe just divide out the -2 from everything. So -4 divided by -2 is 2. And then -8 divided by 2 is 4. And then 2 divided by -2 is -1. So then maybe I want to look at the variables now. So I'm taking out 1A, so I have 1 left over. And then I'm taking out 1B, so now there's no more B left. So there's like this awkward space in my answer, but don't worry about that. I'll rewrite it. Then from the -8AB squared, okay, so I'm taking out an A, so now there's no longer an A. And I'm taking out 1B, but there's 1 left over, so there's a B next to the 4. And then with the 2AB, I'm taking out 1A and 1B, so there's no variables with that -1. So that's actually my answer. And the OCD person in me, I want to rewrite that because I don't like how spaced out it is. All right, so there's my final answer. And again, if you were to distribute that -2AB to everything, you would arrive back at where you started. Okay, so looking at number 3, that's really annoying that it's off center. I apologize. Unfortunately, I don't think I can fix that. No, sorry. Okay, so I'm actually going to rewrite it because that's annoying. So 15W minus 3V. Okay, so here they share 2 different variables. So there's no variable I could consider a GCF, but the GCF here is 3. And that would give me 5W minus V then. So then in number 4, I like number 4. There's a lot of variables going on, so that's kind of confusing. I always look to the numbers first to see what my GCF might be. So I've got 7, 21, and then I've got -1. So in this one, there's actually no number I can factor out. So now I'm going to look at the variables. So here they've got 2 U's and 2 T's, 1 U, 2 T's, and then 1 of each. Okay, so I know that they at least have 1 U and 1 T that I can factor out. And so that leaves 7 to be the same, but I'll take out a U in the first term, so there's 1 left over, same with 1 T, plus 21 Now I take out one u, so this is now gone, and I only have one t left over. And then when I divide those, this is the most common mistake, is that I'll get students be like, oh, okay, that's my answer, and I'll leave it, okay? But remember, if I check my answer, and if I were to distribute this back in, notice how I wouldn't arrive at the answer that I started with. So I actually have to kind of almost like give a place value for that. But ut divided by ut, well, that's 1, okay? So make sure you include that minus 1 at the end. So number 5, same kind of start here. I'm going to look at my numbers. I've got 10, 9, and -1. So no numbers I can take out. I see that this term has 2 G's and 2 H's. This one has 2 H's but no G's. Okay, so that eliminates G being a GCF. And then this one has 2 G's and 1 H. So each term has at least 1 H that I can take out. And so I'll go ahead and do that. So the 10G squared stays the same, but I take out 1 H, but 1's left over, plus 9. Now there's H squared, but I take out 1, so I've got 1 remaining, minus, and then G squared at the end. And then number 6, my GCF here, well, now I've got a 14 and a 2, so then my GCF amongst those numbers is 2. And then they each share at least 1 C, so I'll take out 2 C. So then 14 divided by 2 is 7, and then I take out a C with 1 remaining, and then 2C divided by 2C is 1. So another form of factoring is doing so by grouping. So when we have 4 terms, what I can do is I can group the first 2 terms and the last 2 terms and factor out a GCF from there. So let's see. I don't think I... Oh, okay. All right. Just want to make sure I didn't have a more zoomed up picture. So looking at number 7, what I'll do is I'm going to group the first 2 and I'll group the last 2. And now I'm just going to look at only the first group right now. Okay, and ask myself what's the GCF of that, and that's 4R. And then I would take that out, leaving me with just Q plus 2. Okay, now I'm going to look at my second group, and my GCF from there is 3. And then that when I divide that out, leaves me with Q plus 2. Now the difference in factor by grouping is now I'm not done. What I'll actually do is I'm going to take that 4R and that 3, and that actually creates my first binomial in my answer. And then my second binomial is actually the Q plus 2. So let me show you something really, really cool. Because if you're like, wait, why are we doing this? Well, the reason is, if you guys remember, okay, if I told you to multiply this answer, okay, back when we first started learning multiplying binomials, I told you take the first binomial and split it apart, right? So we'd have 4R and then the plus 3, and then take the second binomial and write it next to each one. Okay, so if I were to actually solve that, I'm going to do that. So Q plus 2. Okay, so now I'm actually going to distribute, right, the 4R. So, okay, that leaves me with 4RQ plus 8R. Now I'm going to distribute the 3. So that would leave me with 3Q plus 6. Holy cow, I literally just went backwards. Okay, if you were to look at what we have over here versus here, they're flip-flopped. So factoring is the undoing of multiplying polynomials. It's really, really cool. I think that's why I like it so much. So let's look at number 8. So again, I'll group the first 2 terms and the second 2 terms. So from the first group, I can factor out an n. So that leaves me with r plus 5. Now from the second group, so something that you have to know, so I'm going to start this problem, is that you cannot have this term here cannot be negative. So that means I have to factor out a negative. So I'm going to actually just factor out -1, and sometimes that's the case with a GCF, that it's just -1. And so that leaves me with r plus 5. Now something that's also super important to note is that, see how these 2 binomials are the same? If they are not the same, then that means you've done something wrong. So that's usually that's why I always tell students, like, if you feel unsure, check those 2 binomials. So now my final answer comes from that n and the -1 that I took out, and then the r plus 5. So then number 9, again, just group the first 2 and the last 2. So from the first grouping, I would say the GCF is 3 and p, leaving me with n plus 5. And then again, notice how this is negative, so that means I'm going to factor out a negative, and the GCF would be 4, leaving me with n plus 5. And so my answer then is 3p minus 4. That's coming from the GCFs that I pulled out. And then n plus 5. So that is my answer. And then number 10. I actually really like number 10. I would star this. And the reason is it's not in standard form. And I'm writing this out for anyone that's not listening. It's not in standard form. Maybe you're just looking at the video. And I know it's not in standard form because look how 42, that should be at the end, right? Because it has a degree of 0. So I'm actually going to rewrite this. So I've got 2mk minus 12m. So now I'm going to flip it with the negative 7k and then the 42 at the end. So now I can go ahead and group my first two terms and my second. So from the first group, I'd say my GCF is 2m, leaving you with k minus 6. And then my GCF from here, again, I noticed that this is negative, so that's going to tell me to take out a negative. And it's going to be negative 7, and it leaves me with k minus 6. I know I've done it right because this is the same. And so my final answer is 2m minus 7 and k minus 6. So then in number 11, again, it's not in standard form, so I'm going to flip that around. So really this should be going first, right? So negative 2cd plus c plus 8d minus 4. And so I'll group the first two and the last two. And let's see. I actually think, before I even group though, what I'm thinking to myself is I don't like that this is negative, okay? So I'm actually going to factor out a negative 1 right from the get-go. So that's going to give me 2cd minus c minus 8d plus 4. Okay, so now I like this a little bit better. So now I'll group the first two and the last two. So not forgetting that negative 1 that I took out. Just kind of leave it on the side. Don't forget about me. Okay, so from the first group, I'll take out a c. That leaves me with 2d minus 1. And from the second group, I'll take out a negative 4. That leaves me with 2d minus 1. So I know I've done this correctly because these are the same. And so my final answer, not forgetting about the negative 1 I took out in the beginning, is c minus 4 and 2d minus 1. So this whole thing would be my answer. And then number 12, again, it's not in standard form. So I would take this negative 2p squared, write that first. Then I'll write the 3p and the negative 18p and the 27. Now you're probably kind of thinking like, hey, aren't these like terms? Couldn't I combine them? Yes, you can. But I don't want you to, and there's a reason for it. And it doesn't make sense now, but just trust me, okay? Don't combine like terms. We're just going to take out, let's factor out a negative 1. So that leaves me with 2p squared minus 3p plus 18p minus 27. Then I'll factor group the first two and the last two, remembering not to forget about little negative 1 that I originally factored out. From the first set, I can factor out a p, so that leaves me with 2p minus 3. And then from the second group, I can factor out, let's see, that's an 18. So I'm thinking I can factor out a 9, and that leaves me with 2p minus 3. So I know I've done it correctly. And so not forgetting about the negative 1 I originally took out, so negative 1 times p plus 9, those are the GCFs I took out, and the 2p minus 3. That is my final answer. And that is the end of this video.